Alright, Assalamu alaikum everyone. Today we will be doing additional mathematics paper 2 variant 2 for May-June 2023. So without further ado, let's begin. Alright, so first up we have a quadratic inequality. So what I'm going to do is collect all the terms on the left hand side. Plus 16 minus 4 is greater than 0. 3x squared minus 15x plus 12 is greater than 0. Now I can take 3 as common, and x squared minus 5x plus 4 would be greater than 0. Using simple factorization, I can deduce that this would be the factors, this would be the factors, x minus 4 minus 1, x minus 4, all of that is greater than 0. And the critical values would be 1 and x being equal to 4. Now, this entire expression is greater than 0. So, for example, let's just draw a sketch. The critical value 1 and the other value of 4. We're looking for this particular range. So, how do we get that? We take x being less than 1 and x as greater than 4. So yeah, all right, let's move on. We have to express this equation in the completed square form. So taking 3 as common again, 3x squared minus 4x plus 16. This would be equal to 3x squared minus 4x. You add the square of the half of x's coefficient, and you again subtract it so that the entire equation does not change. That's in the brackets, and you add 16. 3x, you take the sign of the x term, my bad, x minus, and the square that you are adding, x squared minus 4 plus 16. So multiply them, minus 2 whole squared, 3 into minus 4 is minus 12 plus 16, and so the answer would be, hold on, so it would be 3x minus 2 whole squared plus 4. There you go. And write down the equation of the tangent to the curve, this curve, at the minimum point of the curve. So the minimum point occurs at 2, 4, where the y coordinate is 4. Yeah, my bad, I should have drawn that, my bad. So yeah, just ignore that. Basically this is the x-axis and this is the y-axis. So the equation of the tangent would be a horizontal line, which is always in terms of y, and that'll be y is equals to 4. Moving on, now we have differentiation. We need to find the coordinates of the stationary point of the curve. Find dy by dx. That'll be 64x plus 1 upon 8x minus 2. You multiply minus 2 with 1 upon 8, you get negative 1 upon 4, and you subtract 1 from the power, you get minus 4 upon x cubed. And you equate that to 0. Find the coordinates of the stationary points. There are multiple points. All right, 64x, multiply the entire equation by x cube, we get x to the power 4 minus 1 over 4 equals to 0. 64x to the power 4 is equals to 1 upon 4, and x to the power 4 would be equal to 1 upon 4 divided by 64. Divided by 64, you get 1 upon 256, and as the power is even, our answer for x would be in terms of plus minus. Taking the fourth root of 1 upon 256, we get plus minus 1 upon 4. So we just plug in the x coordinate, doesn't matter if it's plus or minus, because in both cases it's being squared, so the sign doesn't matter. 1 upon x 1 upon 4 whole squared, you get 32 1 upon 4 whole squared plus 1 upon 8 into 1 upon 4 whole squared, you get 4. So yeah, 4 is a coordinate for both of these minimum points, or if it's maximum, we'll see. 1 upon 4 comma 4 and negative 1 upon 4 comma 4. There you go. All right, these stationary points have the same nature. Use the second derivative test to determine whether they are maximum or minimum points. All right, we take d squared y upon dx squared being equal to dy by dx was equal to this. That'll be 64, and negative 1 upon 4 x to the power minus 3 will get 1 plus 3 upon 4 x to the power 4. Yeah, and we plug in any one of the values, it doesn't matter, as the power is even if it's plus or minus 1 upon 4, the sign gets cancelled. Plus 3 upon 4 1 upon 4 to the power 4 is equal to 64 plus 3 upon 4 1 upon 4 to the power 4. No, you get 256. Now d2y upon dx squared is equal to 256, which is greater than 0, and hence these points are minimum points. There you go, that's the conclusion. Alright, so question number 3. Show that x plus 3 is a factor of so and so. So we plug in x equals to minus 3 and show that it'll be equal to 0. So plugging in x equals to minus 3 plus 3 minus 3 whole squared minus 2 minus 3 whole cube is equal to minus 12. That'll be 23 into minus 3. Do not use a calculator for this. 23 into 3, 9, 9 into 3 into 2, 69, minus 69, and that'll be minus 3 whole squared. That'll be 9, 9 into 3 plus 27, and minus 27 into minus 2, that'll be plus 54. Yeah, and this should be, let me see, yeah, it's equal to 0. Okay, so shown. Okay, moving on. This curve is such that, and the line so and so intersect at the points A, B, and C. These points are such that the x coordinate of A has the least value and the y coordinate of C has the greatest value. Let me underline that. Show that B is the midpoint of AC. Alright. Equating the two, 10x plus 7 is equals to minus 5 plus 33x plus 3x squared minus 2x cube. Now, this is quite similar to the equation that we were given in part A. So we take this to that side, we get minus 12 plus 23x plus 3x squared minus 2x cubed, which is exactly that. So we already know that x plus 3 is a factor. So yeah, all right, x plus 3, divide the entire thing, minus 2x cubed plus 3x squared plus 23x minus 12. This should be into minus 2x squared. We get minus 2x cubed, and 3 into minus 2x squared would give us minus 6x squared. So subtracting the 2, we get 9x squared plus 23x minus 12. Now, apart from that, we should multiply that by plus 9x. Yeah, 9x squared plus 27x. Subtract the 2, you get let me see, minus 4x minus 12. That should be into, yeah, minus 4x minus 12. Remainder is 0. we get minus 2x squared plus 9x minus 4 being equal to 0. And all you gotta do is solve for x. Yeah, 2 into 4 gives us 8, should be minus 8x minus x plus 4 equal to 0. 2x, x minus 4 minus 1, x minus 4 is equal to 0. X equals to 1 upon 2 or x equals to 4. And we also have x equals to minus 3. Alright, the least value here is minus 3, for which we have the coordinate x. This is the x coordinate of A, and the greatest value is this, which is the x coordinate of B. So yeah, let's just find the y coordinates for each of them. For A, y would be 10 into, we see minus 3 plus 7 gives us minus 30 plus 7 gives us minus 23. Yeah, and for B's y coordinate, it would be 10 into 4 plus 7, which is quite easy to do, that's 47. Okay, so A is minus 3 minus 23, B is 447. Now the midpoint of this would be my bad, this is for C, my bad, yeah, C. Alright, for B's y coordinate, that would be, we see 10 into 1 upon 2 plus 7, which is equals to 5 plus 7, which is 5 plus 7 is, yeah, 12. Okay, so we should show that the midpoint of these two should be equal to this. Let's see. AC mid would be equal to 4, add the 2, minus 3 upon 2, 47 minus 23 upon 2, is equal to 1 upon 2, that's, my bad, hold on, that's negative, that's not negative, 1 upon 2 and 47 minus 23, let's do that, hold on, 23, 4, 2, 24, 24 over 2, which is indeed equal to 1 upon 2 and 12, which is identical to 1 upon 2, 12. Shown. Moving on. These two variables x and y are related by the equation so and so. Alright, for this particular range, given that x is increasing at a constant rate of 0.04 radians per second, find the corresponding rate of change of y when y is equal to 3. Okay, so first of all, let's just find out the value of x when y is equal to 3. That'll be tan 1 minus x, yeah, and that'll be tan of 1 minus x being equal to 1, and 1 minus x should be equal to tan inverse of 1 is 45 degrees, which is in radians pi upon 4, and x would be equal to 1 minus pi upon 4. Okay, now setting up the chain, we get what we need is find the corresponding rate of change of y. Dy upon dt should be equal to dy upon dx into dx upon dt. Okay, we already have this. What we need is this at this value of x. Okay, that shouldn't be that hard. Dy by dx would be equal to, the constant gets cancelled out, we have sec squared 1 minus x into the differential of whatever is in the angle, that'll be into minus 1, should be minus sec squared 1 minus x. Now sec squared does not exist in our calculators. What we can do is use the identity of sec squared being equal to 1 upon cos squared, that'll be equal to negative 1 upon cos squared 1 minus x. So at okay, we already have the value of 1 minus x as being equal to pi upon 4. So at x being equal to 1 minus pi upon 4, all we gotta do is put in this in this. We get negative 1 upon cos squared pi upon 4, which is equal to, let's see, negative 1 upon cos pi upon 4 whole squared. We get minus 2. Okay, dy upon dt is equal to minus 2 into dx upon dt was 0.04, and let me see, yeah, minus 2 into 0.04, we get negative 0.08. Let's see if that's correct. Minus 1 upon cos pi upon 4 radians whole squared minus 2. Yeah, so yeah, that's that, and your answer is indeed negative 0.08. All right, for question 5 we have a linear log question. Variables p and t are known to be connected by this relationship where a and b are constants. Find values of p are found for certain values of time. All right, show that a graph of lgp against t will be a straight line. So applying lg on both sides of the equation that is given, lga b bar t. Now using product rule we can separate these two. That will be equal to lga plus lgb bar t. Now rearranging this would be lgp is equals to lgb into t, because this comes over here, and a plus lga, and this is identical to y is equals to m x plus c, the straight line form. Yeah, moving on, we have this particular graph and we have to find the values of a and b. The graph shows values of b. All right, it has given us some coordinates. Okay, now when you look at the equation I formed above, lga is basically equal to the y-intercept, which here is 6. So lga is equals to 6. A would be equal to 10 to the power 6. There you go. Moving on, lgb is equals to the gradient. lgb is equals to m, which is equal to, we can use the given coordinates, y2 minus y1 upon x2 minus x1, 6 upon 14, which is equal to 3 over 7. Yeah, this is the value of lgb. So b would be equal to 10 to the power 3 upon 7. Quickly writing this, a will be equal to 10 to the power 6 and b would be equal to 10 to the power 3 upon 7. Okay, using the graph or otherwise, find the length of time for which p is between 100 million and 1000 million. Okay, that's interesting. Hold on, log of 100 10 to the power 6. What we can do is take it, or otherwise we should use our equation which we just found. Okay, making t the subject from here, let me just copy it down. Hold on a second. There you go. Need to make t the subject. All right, so making t the subject, lga, my bad, hold on, lgp minus lga upon lgb would be equal to t. Yeah, so all you have to do is plug in the values. T is equal to lgp is 100 million, which is equal to 100 into 10 to the power 6. 100 to 10th power 6 minus LGA, we already know that's equal to 6 upon LGB, which is equal to 3 upon 7. So we get answer for this as over 3 over 7, hold on, log 100 into 10 to the power 6 minus 6 upon 6 3 over 7. We get 14 upon 3. Now 1,000 million T is equals to LG 1,000 into 10 to the power 6 minus 6 upon 3 over 7. Let me do that quickly. You get 7. Okay. Subtract 14 over 3 from 7. You get 7 over 3 as the time, which is equal to 2.3 units. I don't think we have any units. Yeah. 2.33. There you go. Alright, binomial theorem. Find the first three terms in the expansion of 1 plus x upon 7 to the power 5 in ascending powers of x. Simplify the coefficient of each term. Okay. As 1 is in the power, we have to just use a simple rule of 1 plus nx plus n into n minus 1 upon 2 x squared and so on and so forth. So n is 5 into x upon 7 plus 5 into 4 upon 2 factorial into x upon 7 whole squared is equal to 1 upon 5x upon 7 plus 5 into 4 upon 2, that's equal to 10 into x squared upon 49, and hence our answer would be 1 plus 5x upon 7 plus 10x squared upon 49. Okay. The expansion of this, where n is a positive integer, is written in ascending powers of x. The first two terms in the expansion are so and so. Find the value of n. Okay. So quickly we can write this expansion over here. Now, as far as this expansion is given in the question, it goes as far as the x term. So we don't need to write this. All we have to do is write till here. Okay, yeah. Expanding this also till the x term, that will be 1 plus nx, and yeah, we don't need to expand further. 7. Alright, I'll just multiply 7 here as well. Yeah. So 7 plus 5x, 7 into 5x upon 7, that will be 5x, 7 plus 7 nx, and we don't need to multiply with this. Yeah, be identical to 7 plus 89x. So collecting x, taking x as common, we have 5 plus 7nx being equal to 89x. X is cancelled. 89 minus 5 is equal to 7n, and n would be equal to 89 minus 5 upon 7, which is equal to 12. So yeah, there you go. That's the answer. In the expansion of this, where k is a constant, the coefficient of x4 divided by the coefficient of x squared is 5 upon 8, where the coefficient of x is positive. Form an equation and hence find the value of k. Okay. Now, as x is in the second term in our binomial, the value of the power will be equal to the value of r in NCR, where n is equal to 8. Okay, so 8 combination 4 into k to the power 8 minus 4, that's 4, into minus 2x to the power 4. Yeah, that'll be equal to 8 combination 4 into minus 2 to the power 4. We get 1 1 2 0 k to the power 4 x to the power 4. There you go. And the same goes for x squared as well. 8c2 into k to the power 8 minus 2, that's 6, into minus 2x to the power 2. We get 8 combination 2 into 2 squared, that's 112 k to the power 6 x squared. Now the coefficient of x to the power 4 and x squared is 5.8, so 1120 k to the power 4 on 112 k to the power 6 equals to 5/8. 1 that'll be, okay, yeah, those two cancel out. 10 upon k squared is equals to 5/8. K squared is equals to 10 over 5/8, that's equal to 16. K is equal to plus minus 4. Now the coefficient of x is positive, so 8c1 into k to the power 7 into minus 2x to the power 1 would be equal to 8 k to the power 7 into minus 2x. Okay, for this to be positive, we would need this number to also be negative, because we are multiplying with a negative number and two negatives make a positive. So as it is already positive, we need this to be negative, and hence we get as k being equal to -4. There you go, that's the answer. Anyways, functions. F of x is equals to, my bad, that's differentiation, giving our answer as a simplified algebraic fraction. Alright, f prime of x would be equal to, applying the product rule, my bad, hold on, 1.2. okay, you take the power down, you write this expression inside the bracket as it is, you subtract 1 from the power into the differential of whatever is in the brackets. That is this particular bracket. That'll be 4x minus 5 to the power 4, subtracting 1 from the power, into 4. And hence, simplified algebraic fraction, we'll get 4 and this cancel, yeah, we get yeah, hold on, 10 4x minus 5 to the power 4 over 3 plus 4x minus 5 to the power 5 negative, so that's under root. There you go, that's your answer. Alright, variables x and y are related by the equation so and so. Using differentiation, find the approximate change in x when y increases from 10 by the small amount 0.01. Okay, now small change in y upon small change in x is approximately equal to dy upon dx. We are already given the small change in y, which is equal to 0.01 upon small change in x, being approximately equal to dy upon dx. So what we need to do is find dy by dx at x is equal to whatever we will get when we put y is equal to 10 into the equation. So doing that, 10 is equals to 5x upon 3x plus 2. 5x is equals to 30x plus 20. We get 25. X is equals to uh, minus 20, yeah. And x is equals to minus 4 over 5. So as at x is equals to minus 4 upon 5, we need to find dy upon dx. Okay, so let's do that. Dy upon dx is equals to, applying the quotient rule, v u prime minus u v prime over v squared. That'll be 15x plus 10 minus 15x. Is that true? Yeah. Upon 3x plus 2 whole squared. These two cancel and we need to find dy by dx. 10 upon 3 at minus 4 upon 5, so might as well do that quickly. Plus 2 whole squared, we get 10 upon 3 minus 4 upon 5 plus 2, hold on, whole squared. We get 62.5. Yeah. Let's see. Let's confirm using our calculators. 5 alpha x upon 3 alpha x plus 2 at x being equal to negative, hold on, negative 4.5. 62.5, that is correct. Yeah. Let me see if anything may be wrong. Yeah, this is correct. 5 into negative 4.5 divided by 3 into negative 4.5 plus 2. Yeah, okay. So small change in x is equal to 0.01 upon 62.5, which is equal to 0.01 divided by 62.5. 1 upon 6250, that is equal to, let's quickly write the answer, 1.6 into 10 to the power minus 4. There you go. Now differentiate this with respect to x. Dy upon dx would be equal to, applying the product rule, v u prime plus u v prime. We get 3x squared ln x plus x squared. Okay. Anyways, now hence find the integral of this. Now as you would notice that this isn't exactly what we have here, so what all you have to do is expand the whole thing. X squared upon 3, 2 into 2 upon 6 is 1 upon 3, yeah, plus 3 upon 6 is 1 upon 2, so x squared ln x upon 2. Yeah, okay. Now we can find the integral of this, we cannot find the integral of this, so we need to use the answer to our previous question. So the integral of 3x squared ln x plus x squared is equal to x cubed ln x. We need to transform this into this. Hold on. Into this. So let's do that. That'll be 6 and 1 upon 2 x squared ln x plus the integral of x squared is equal to x cubed ln x. And yeah, there you go. Almost there. X squared ln x is equals to 6 cube ln x. The integral of x square is mine. We'll just take that to this side and it'll become negative x cubed upon 3. We shift 6 to that side and hence the integral of 1 upon 2 x squared ln x is equal to x cubed ln x upon 6 minus x cubed upon 18. Yeah, there you go. So yeah, the integral of this x squared upon 3 plus the integral of x squared ln x upon 2 is equal to, we can find the integral of this, which is increase the power by 1 divided by the new power, plus we already know the integral of this, which is this x cubed ln x upon 6 minus x cubed upon 18. Writing this nicely, also remember the plus c, x cubed upon 9 plus x cubed ln x, or we can actually collect these two, which would be equal to 2x upon 18. Yeah, we get this and upon this plus c. There you go, that's your answer. Alright, moving on. The curve has equation this, where x is in radians, normal to the curve at the point this, cuts the y-axis at the point P, find the exact coordinates of P. Alright. First of all, what you have to do is find dy upon dx, which is equal to a negative sine x upon 4 into the differential of the angle, which is equal to 1 upon 4, which will be equal to negative 1 upon 4 sine x over 4. At x being equal to 4 pi upon 3, dy upon dx would be equal to, let's find out, negative 1 upon 4 into sine of pi upon 3. The 4's cancel out. We get negative under root 3 over 8. Alright. Now, this is the tangent's gradient. We need to find the gradient to the normal, which would be equal to its negative reciprocal, 8 over under root 3. Okay. When x is equal to pi upon 4, y would be equal to, let's find out, 4 pi upon 3 divided by 4. We get cos of pi upon 3, let's see, 1 upon 2. Yeah. So we use this equation, y, we have the coordinates as 4 pi upon 3 and 1 upon 2. Y minus y1 is equals to m, which is this, x minus 4 pi upon 3. Now it says exact coordinates of P. So we already know at the x-axis y is equal to 0, minus 1 upon 2 is equals to 8 over under root 3, x minus 4 pi upon 3. Now rearranging this, we get negative 1 upon 2 into the root 3 over 8. We get minus under root 3 over 16 plus 4 pi upon 3. Yeah. So there you go, that's your answer. 4 pi upon 3 minus under root 3 upon 16, comma 0. Moving on, how many questions do we have left? Just the 2. See? Yeah. Alright. Kinematics. A particle travels in a straight line so that t seconds after passing a fixed point, its velocity v ms inverse is given by these two equations. Alright. The total distance traveled by the particle between t and k, between 0 and k, is 13.4 meters. Find the value of k. Okay, all right. So to find the distance from velocity, we need to integrate velocity, and that will be equal to the integral of this, label this vi, that will be equal to e to the power t over 4 divided by the differential of this, which will be equal to negative 1 upon 4, which is as good as 4, yeah, plus c. Now it is a fact that at time equals to 0, the displacement of the object, which is what is given by integrating velocity, would also be equal to 0, because when you're starting from a fixed point initially at time is equal to 0, right at the beginning, you have not moved, so the displacement from the fixed point would also be equal to 0. So 0 is equal to 4e 0 upon 4 plus c, and c would be equal to negative 4, and this would be 1, so might as well write minus 4. Okay, so we have, let's label this as si being equal to 4e to the power t upon 4 minus 4. Okay, now let's integrate this, because that will give us the displacement at this time. So integrate s2 would be equal to the differential of v2, which would be equal to, now as you can see, this can be written as this. So increase the power by 1, we get 16e t to the power minus 1 divided by the new power, which is equal to minus 1. We get negative 16e over t plus c. Now for this range, we have the value of, we can use this equation to help us find the value of c. Why? Because 4 is included in both the ranges. Hence, at t is equals to 4, the displacement would be, let's use this equation, my bad, this equation, 4e t upon 4 is 1, minus 4 will be equal to 4e minus 4. That's at t is equals to 0, s is equals to 4e minus 4. So 4e minus 4 is equal to, using this equation, minus 16e upon 4 plus c. C would be equal to 4e plus 4e, because 16e, negative 16e upon 4 is negative 4e. Taking it to that side will make it positive. 8e minus 4. There you go. Finally, the displacement is given by negative 16e upon t plus 8e minus 4. Finally, we can equate it to 13.4 negative 16e upon k minus 8 plus 8e minus 4. Solving for k would be, that will be equal to, let's first of all rearrange 13.4 minus 8e plus 4, and it will be equal to negative 16e upon k. K would be equal to negative 16e upon this. Yeah, so let's work this out in our calculator. Negative 16 alpha e, 13.4 minus 8 alpha e plus 4, we get 10.00 something, doesn't matter. Do 3 significant figures, that'll be 10 seconds. Yeah. Let me just write it to 3, yeah. Alright, last question. This should be easy. Triangle OAB, okay, C is the midpoint of OA. The point D lies on CB such that CD ratio DB is 2:3. So this is 2 parts, this is 3 parts. and OC is equal to C, and as C is the midpoint of OA, this will also be C, and CB is, well, it's B. Okay. The point E lies on AB such that OE is lambda times OD, and this relationship where these are scalars. Find two expressions for OE, each in terms of BC and a scalar, and hence find AE ratio AB. All right. Okay, first of all, OE. That will be equal to it's already given that it's lambda times OD. So what we can do is find OD first. OD will be equal to OC plus CD. That will be equal to C plus 2 over 5B. Yeah. And OE is lambda times C plus 2B upon 5. We got that first equation. And moving on, finding the second equation for OE, we can use this given relationship. AB would be equal to, let's see, hold on, yeah, AB would be equal to AC plus CB. Yeah, that'll be equal to minus C plus CB is, that is B. And hence AE would be equal to mu times of minus C plus B. Alright, OE would be simple OA plus AE. That will be equal to 2C plus mu times minus C plus B. Equating the two, lambda C plus 2B upon 5 would be equal to plus 2C plus mu times minus C plus B. Alright, lambda times C plus 2 lambda upon 5B is equal to let me see, 2 minus mu C, yeah, and mu plus mu B. Okay, we know that lambda is equal to 2 minus mu. Comparing the coefficients, 2 lambda upon 5 is equal to mu. So lambda is equal to 2 minus 2 lambda upon 5. Solving for lambda, we get 5 lambda, 10 minus 2 lambda, and 7 lambda is equal to 10, and hence lambda is equal to 10 upon 7. Solving for mu, we get mu is equal to 2 into 10 upon 7 upon 5. That is equal to 2 into 10 upon 7 divided by 5, 4 upon 7. Okay. Find AE ratio EB. Almost there. We already know AE, which is equal to mu times minus C plus B. AE equals to 4 upon 7, which is mu, minus C plus B. Yeah, there you go. And EB would be equal to, let's see, EB would be equal to AB. That will be equal to AB minus AE. Yeah, AB minus AE, which is equal to, let's see, AB is minus C plus B minus 4 upon 7 minus C plus B. Now collecting all the terms, we get EB equal to minus 1 plus 4 upon 7. We get minus 3 upon 7 C, and 1 minus 4 upon 7, which is equals to plus 3 upon 7b. We can take 3 upon 7 as common. 3 upon 7 minus c plus b. And we need to find the ratio of a, e, and eb. Yeah. So 4 upon 7 minus c plus b ratio 3 upon 7 minus c plus b. You can make out that AE ratio EB is equals to 4 ratio 3. And yeah, there you go. Thanks for bearing with me, and Allah Hafiz.